In part B, we have to factorise the following expression. We know from part A that x minus 1 left us with a remainder, and we're aiming to find a factor first of all. We're going to use the rule that obviously the f of a, if that equals 0, i.e. there's no remainder, then x minus a is a factor of the expression. Now, because we've already used 1, I'm now going to use minus 1. So the f of minus 1 will be 9 lots of minus 1 cubed plus 6 lots of minus 1 squared minus 5 lots of minus 1 minus 2. Substituting in, we get minus 1 times 9 is minus 9, minus 1 squared is 1, times 6 is 6, minus 5 times minus 1 is 5, minus 2. That gives us minus 11 plus 11, which is 0. So we now know that x plus 1 is a factor. Remember, if the f of a is 0, then x minus a is a factor, and minus 1 is plus 1. Now we've got that, a preferred method that I like to use is to compare coefficients, because what we know now, because this is a cubic, that x plus 1 multiplied by some quadratic ax squared plus bx plus c must be the same as 9x cubed plus 6x squared minus 5x minus 2. So what we can do now is we can look at how this would expand out if we were to multiply everything through by x plus 1 and compare it to the terms on the right hand side. In the first instance, the only way we can make a cubic term on the left hand side is if x was multiplied by ax squared. That would give us ax cubed. So we know that a must equal 9. So that was comparing our x cubed terms on both sides. If we were then to look at our x squared terms, well, we can make x squared two ways on the left hand side. We have 1 times ax squared, which would give us ax squared on the left hand side, but also x times bx would raise a squared term. So that would give us bx squared, so the coefficient there would be b. On the right hand side, we can see that there's only one x squared term that has a coefficient of 6. So I know that a plus b must equal 6. I now know that a is 9. So 9 plus b is equal to 6. So b must equal minus 3. Finally, we just need to compare the constants. The only way in which we can just have a number occurring on the left hand side is if 1 was multiplied by c. So looking at our constants, on the left hand side we simply have c, and on the right hand side we have minus 2. So we now know that a is 9, b is minus 3 and c is minus 2. So we have x plus 1, 9x squared minus 3x minus 2 has got to be equal to 9x cubed plus 6x squared minus 5x minus 2. Now we haven't quite finished yet. We now need to factorise the quadratic we have on this right hand side, and it does in fact go into two brackets. Both brackets will have 3x and 3x, and then obviously the constant helps us here with 2 and 1, and we would need to make the 2 negative and the 1 positive, which gives us an exact factorisation. So that is the three brackets that would multiply together to give us 9x cubed plus 6x squared minus 5x minus 2.